Hi, I'm Shadow of Shadow Gaming, bringing you Programming with Shadow, episode number 11. And today we're going to be talking about object-oriented programming. So in C Sharp, what we've done so far is what would be known as procedural programming. Write out our code and then we execute it. Object-oriented is another way to think about code. So C Sharp's multi-paradigm, those are two of the paradigms. There's others, but object-oriented is a big one. Me, it was the next spot where we went to, and that's why I'm following the path here. The idea with object-oriented programming is you started to look at organizing code around real-world entities, real-world things. That's where the objects are things that have state. So state you can think of as data. It has or maybe attributes, something that tells you about the object, and they have behaviors or methods. So something they can do, like an example I'm going to do. Say we have a car or a car, so a car can have a color. So we could say it's a property or field, attribute, or state. It's color, and maybe it's red, so we have a red car. Also has behavior, like we start the engine, we drive, do something. The car can do something. That's the idea with object-oriented programming. It helps pull everything together in a way that we can think about the world through code. Maybe our code has to match the world a little. In C Sharp, all that revolves around classes. So a class is basically, you can think of it as a blueprint for creating an object. We have an object, and where that you can have many objects that are all created based on this. So as we get in, there's some terms you run into with object-oriented programming that I'm just going to mention here. We'll work on building up the ideas of these. The first is encapsulation. So idea there is you're putting in data with the methods that it operates. So you're putting things together where they belong. Second one here is abstraction. You're hiding in the internals. So you're making complex things only show on the inside. So like if someone using the object wouldn't know how complex it. Maybe you have a lot of steps, like maybe starting the engines more than or actually did a lot. You wouldn't have to show the user that; they'd just know start the engine and you're good. You can think of that with real world objects. Really go out to your car. You hope that turning the ignition and starting it, you hope that your car starts at that point, and hope you've been able to abstract away all the operations that's actually happening. The next one's inheritance. I'm probably not going to talk about inheritance today. That is, you can take a class and you can take the properties. You can get them from other classes and use them and adapt them for your needs. Maybe for my car, maybe I have maybe a inheritance from my car. Maybe I have maybe I set some other properties, methods, whoops, methods that are different than what the original car has. The last one's polymorphism. Means many forms, basically. I think that's what I would say it means. The idea there is you can have same method or properties behave differently depending on happening what the state of the object is. There's three types of polymorphism. We'll look at them. Another one you'll hear that I'm not going to talk about is solid principles, and it's acronym H. We'll look at that in the future, but not right at the moment. Well, before we go any further, let's start looking at actually class. I'm going to create it in a new file. We haven't done this yet, but basically in C Sharp, you're going to just create a new file. We're going to do car.cs. created. Here we go. So there's a little more boilerplate with classes than we've seen before, but they're not too complex. The first thing you tell it is how accessible you be. There's several options. What we're going to do for now is just a public class. And we put its name and the scope. The public just means it should be accessible all over the place. The second keyword there, as we said, the C# mechanism for objects is class. Class is a blueprint thing. Here's my car class. So you can use this to create objects. Let's have data. And I'm going to probably say fields for the future. I might say attributes. I think that's technically how I've heard them. Attributes, data. Then you'll have a constructor. That's the way to build the class. And finally, you have the methods or actions, what have you. You might also hear properties in C here as well. I can spell it. I'm going to probably, future, I'm probably going to favor these and the field property. You'll see them all here and there, and depends on what you're looking at. If you're looking at Sharp, those might be the more common. If you're looking at, basically, there's some way to hide data and actions. Let's start with the constructor. The idea of a constructor is you creating the object. It's going to have the same keyword here, public. We're saying everyone has access to create car. There we go. You have a constructor and it does nothing. Let's add some data, so something about the car that makes it useful. Let's do public string color. Now let's pass in color here. So now we're saying the car takes the parameter color. There, that's very unhelpful. So I'm going to put an underscore. So that is just a convention. It's just C# convention. Or where you might see something different wherever you look. Some places might do some other convention there. In fact, for this, I would actually probably say the capital, because it is public. If it was private, I would definitely say underscore. But since it's public, so this is just saying, okay, when you construct a car, get a color, set the color to car's color to be that color. Little annoying, like seems like shouldn't be useful, but we'll see how it is later. Let's do a method of public void drive. Like this. Now we have us a little car and we can test it and see if it works. Go over here to program. Do car equals new car. Let's say red. If for no other reason that it is red short to top. So there we go. Let's see what happens if we run this. Red car is driving. So there we go. We've created a car object. We've set the initial color to red. We've called a drive method. Over here, we've created a constructor. Give our class some data. Give it something it can do. There we go. That's a very basic intro to a class, and not a lot happened. The one thing you might see here, see the dots here. I'm getting a new expression can be applied. What you can do there, you technically don't need car. That's a newer C# feature, but you can see car, new this, and hard enough to know new here. I'll probably switch to that format in the future, but for now I'm gonna use the full car equals car. But in the future I'll probably just drop it. Might not even say anything about it, but that will happen eventually. Let's look into the first one here, encapsulation. So right now, if I want to over here, if I want to do something with the car color, I could do color equals green. Now if I drive the car again, now it changed the color. So right now I'm not encapsulating the color. I'm allowing it to be used outside of this, and that's probably not what I want to do. I mean, it may be. Who knows? We may want to be able to change your color instantly. My example here, we're going to look at. So this is the field. That is, it's just data there, and I can change it freely. I can make it private, but that's not going to be exactly what I want. Let's look at the third word here, property. And not properties, property. Those are the most common you're going to see in C#, and there's some niceness with them. They help you hide away the other word there, abstract away information you don't need to know about. Like as far as from the outside, all I need to know is the color. I don't need to know any rules about it, and nothing really I'm going to actually control about it. Let's do public string color, and let's add this behind it, get and set. Now this is a property. In fact, it's an auto property. So there's a little bit going on behind the scenes. Now this is this should be the same thing. Go over here and we add back green, and in fact, it'll still be wrong. It still allows us to change that. Now, though, we have an easy fix that. All we have to do is say private. Now, we get a syntax error. Or cannot be used because it's inaccessible. Now, we can't just change the color. And we'll see it works the same as it did before. There gives us a little bit more functionality. Now, let's say we do want to change the color, though, but we want to be able to control it. Let's add a public void paint. We might want to paint the car color. So let's say we can't. In real life, you would probably want to be able to paint it the same color, like say if you got scratches or something you fix. We're going to say here if we need to pass in a color. Color equals new color. We're going to say that's not allowed. Let's do console right line. Paint. Color. So there we go. Now we need an else. Let's see what I want to say here. equal dot. Let's do painting car. We need to actually change the color. Equals new color. What happened there? Over here, I can't do that. I can't say my color equals green. String. Can't say that over here because it tells me it's wrong. And if I run it, you'll get an error. It'll be that same. Inaccessible. However, I can change it over here. This seems fine. It doesn't say anything problem with doing it here. That's where the private comes in. So private tells you that you can only use this color. We can only set the color here inside this class, inside car. So the only time we're doing that is here in constructor. We set the color to whatever the initial color is. Or down here in the paint, when we paint it, we switch to color for the new color. Let's do green, and now if we drive the car, now we get the same behavior, but we're now more controlled. We can say if it's the same color or not, if there's other things we need to change. We've just hidden from the user any of the problems. Like maybe there's a lot more that needs considered of painting one if check. Maybe there's a lot of other work we have to do. We've just encapsulated that in the car class, so it knows about what it needs. Also abstracted away that information from the user, so they don't have to deal with it. They don't have to worry about it. They just know they can paint the car green. They don't have to know that all the internal details. So that brings us to another word we haven't heard of yet. So we could say that the car, or you can say what data of a car is. There's two words for that. I may not be able to spell one of them. There. Let's do aggregation and composition. So these are two ways to describe how properties relate to the class. In general, you want to favor composition over aggregation. The reasoning for that is that aggregation is really easy to change. That was the first one I had here when it was this would be aggregation. It's uncontrolled. We can make changes wherever we want. The second one here is composed of this. Set the color, we control how it's accessed, so we control everything about it. That makes it easier later when we talk about testing. You'll find that composition is really nice, aggregation, and later also inheritance tend to not be hardly as nice as if we can do it by composition. So let's do something new. Let's add another value for composition. Down here at the bottom of the file, I'm going to do public class engine. Click here, dot. I'm going to do move type to engine.cs. What did I just do? I created a new class, so a second class, engine. Now we're going to put this, we're going to constructor engine. So there we go, we have a constructor now. So one thing about constructors, however, is that if they don't do anything, optional. So I don't think I want to do anything with it. No, let's not Let's show that they're optional first. I'm trying to think if I wanted to actually do it. Let's instead say that this is aggregation, so you don't have to provide this at the start. We're going to provide it. Let's do aggregation horsepower. Let's also provide a method. Nothing's really happening here, but we could have different things that happen here, but the user would never need to know about it. We wouldn't have to deal with that. So now we have an engine, we have a start. We also have a stop. We might add that here in a minute. Add the engine. Let's add a second property. So here we're going to use composition again. We're going to say a car composed of a color, and then that means it can't not have one. It always has to have one, but we can control what it has in the constructor. It's public engine. So there's something new we haven't seen. On top there is one I've created now of engine. Get private set. I'm going to favor that spacing for these, but it doesn't really matter. So now we've got an engine. So now we need to pass in that engine, so we can pass it just like we do other variables. Maybe we don't even want to. Maybe this is probably wrong. Maybe we don't want to. Maybe we do. Maybe we want to open hood at some point. Now this is going to do. Let's add a method here. Add a third method of. Well, I don't know why it's switching. Start engine. And it's all about right line. The color car is ready to go. Something like that. Now, if we come back over here, now it says new could be second one. There's no argument given that corresponds to the required parameter of engine. Now we need to give it an engine. So let's declare one. Now we can set the horsepower. We don't have to, but we can. Let's say engine horsepower equals 300. In fact, we're not using it, so that didn't need that. We'll use it here just so we can show something else new. There we go. Now our car has an engine. We do. There we go. Starting engine, start. Car is ready to go. Car is driving. So forth. The one thing we can do now, let's go back over here to engine. Add a field here of it started. I'm going to make it a property. Get private set. The very last thing here is started. Let's call it is running. Is running equals there. Now we have a little more information. So we know we can't drive if engine dot is running. It is running. We know we can save this message. Else on our right line. The car is not started. First. There, we've added a little more functionality. So now if we try to drive the car before we start it, we should get that message. There, the car is not running. Start it first. And we start the engine. Engine started. Ready. The red car is ready to go. Red car is driving. Tank the car green. Driving it. Just a little token example of what we can do, but this is showing a little how we can use the car, the engine. So something else. Let's say we want to create another car. We can do that. It's just a blueprint. Blue car. Now if we do the two dot start. Now we should be able to see both of these running. There we go. That was easy enough. So a class is just a blueprint. It tells you how to make a car and make as many as you want. You can make them in an array and store, or in a loop and store them in an array as well. So you have many cars if you need. So here's something else. Let's say we do this instead of creating a new car. What if we do so this, now we should see it still says green car down here. Yep, there's green car twice. However, what if we do this? What if we copy it off before we paint it green? So now what happens to my car 2 here? It's green as well. What happened? We copied it before we did it. Should have been red, right? Copied it and then we did it. So this is where something changes. Most of what we've done so far, we've been passing around value types. So that is, they have a value and you pass that around, and when you pass it, you get a new value. Objects are passed around as reference. So the idea is that with a value type, you can say, okay, I have this integer here, pass it around. With reference, we don't know. With an object, we don't know how big the object is. Like we can see, like if we want to, we could do sort of size of my size of not right. Oh. Maybe I can't do that. Never mind. Interesting. But basically, the size is variable. I was actually surprised I couldn't do that, but like just doing from green to blue to red, one of them is going to be slightly different car, slightly different size. How C# deals with that is it passes by or by reference. So references in memory, it's just the address. It's just the address of where the car is at in memory. So it passes that reference around. Then here we pass this reference, but then we change the base top paint. So then the reference and the original both get the movie color. That leads you to occasionally seeing another constructor. So what we'll do here is copy constructor. I don't see these too often, but I do occasionally see them. So we have something like this car. There, we're saying we want to make a copy of a car. Color equals car.color. Engine equals engine. We may not want to do that because that's passing the reference to an engine as well. We may want to do. Let's do this. New engine. Wrong. I think that's right format, but I'm not at it wrong. Yeah, there should be a. I thought it was that. Horsepower. Oh, there it is. Yep, there we go. Never mind. So there's different format. Like, that's a format. So this is saying construct us a new engine. Notice there's no parentheses. Then we give this. This is okay. So when I create the new engine, go ahead and set its horsepower to equal this. There. Now we've copied a new car and we've done a new engine. Now if we go do that over here, equals new car. Pass in my car. Now we're going to have a green and a red car. There we go. Now the original's green. Copy of it's red though. You occasionally see that, and sometimes it can be useful, sometimes it might not be. Let's do something. Oh, mentioned that copy construction. So here, these are the same name, but the values are different. This is something called overload. So I've overloaded my constructor. I've given multiple types of instructions. You do a quick Google search here just a second. A second. Looking for an example, but I'm not finding it. Okay, so yeah, I believe this would be called ad hoc polymorphism. So polymorphism is a way of saying I'm basically I'm overloading the constructor. I have multiple ways I can constructor. That can be useful occasionally as well. Sometimes it's not, sometimes it is. In this case, maybe we want to make a copy, and then yeah, sure, we could use that. In other cases, that might get more confusing. Rather than that's one of three types, though. Now we've seen 3 out of 4 of these. We haven't seen anything out of inheritance, though, and there's other types of polymorph. But I actually feel like that's actually a good place for the first lesson. We've at least talked about a lot of the concepts and start throwing them into examples. Yeah, let's recap. So in C Sharp, we've looked at their object-oriented programming. The idea of creating objects to represent real world things. And objects have data and operations. The data we're calling fields or properties, and operations we're calling methods. So we've seen very briefly how encapsulation, putting all the information we need together, abstraction, hiding away unnecessary details so the user doesn't need to know about them. Haven't looked at inheritance. Then I've had a little bit of an example of polymorphism. So we looked at how to create a new class, looked at its access modifier. So we've used public. We also seen private, or also mentioned private set. There's others as well. You might see internal, protected. But public and private are the most common, and that's what we'll see for the moment. In the next word, we declare a class. Class is C-sharp's way of doing object-oriented programming. Basically, a blueprint that says when I create this class, that it'll have these values. Mentioned attributes, data, fields, properties, whichever terminology we're going to use. Like I said, for C Sharp, fields and properties are probably the two I'm seeing. Here we've created 2 properties, color, and it's these are auto properties, meaning there's no backing field. So sometimes you'll see some private, like maybe a private string and underscore color up here. We'll look at them later, but now we don't need them for this example, so no need to actually do anything. We also set it private. A private set, that means you can only set it inside of the car. You can't do it outside. So can't change the color. We decide which. So the air usage like this is called composition though, because we pass in the color and can't actually set it from the outside. So whatever we set it pass in is what we have on the other side. That has really useful benefits later when we talk about testing. For now, it'll just seem like it's just a lot of work, but we'll see that sometimes a lot of work can pay off. We looked at 2 different forms of constructors, a copy constructor and a regular constructor. This would technically be there's one more constructor, a default constructor, and it would just set the default value. This would be called a parameterized constructor. I take different parameters at those. The last one here is a copy constructor. It takes in a car and copies the value. We need to do that because objects are passed by reference, but with references. Reference is just a way in memory. It's a memory address basically. Okay, my car is at this address, and go to that address and see the data. Thing with that though is that when you copy it without a copy constructor, without copying the address, it's all the same thing. So if you change one, you change both. So that's where the copying. Third, here we looked at methods and reading methods about another method. Basically, the idea of methods is how you interact with the object, and that's how you use the data in the object. That's one of the key things with object-oriented programming is keeping the data and the method separate, keeping them focused on what they're doing, keeping them, letting a method have a single responsibility, basically. So everything I need to know about driving is here. I check if the engine's running and error if it's not, so forth. Oh, look to here at engine, and engine has an implicit constructor, no constructor declared. So it's technically a default constructor, just there's not one. And that works all right. It just has data on the inside, so horsepower defaults to 0, so we know 0 value is running. I think defaults to I could set that to say it starts in false. Probably be a good call there. But then we looked at creating a new engine, a new car, using the constructors to construct it. Then we looked at how we can use the methods here. One thing I didn't look at was how we can use the data. So let's do one example here. So that's sample though. Console line. There we go. It's as easy as that. We just point to the public color. So add a public get if correctly. Get here. There's no value, but that means it defaults to public. I think public's not even valid. Yeah. So it gets whatever the value is here. Just make set more private or more restricted private. But here, if we run this, we should see the car2's color is red. There we go. So there we use data, used methods. The other. No, I believe that probably covers what I would like to make. Oh, talked about aggregation, just very, very lightly touched on. The idea of aggregation is that you have a car or have an object and it has things in it. So, a good example. Maybe you have a bag and it has an item in it. I don't know what you have. Maybe you're writing a game and it doesn't have to have an item in it though, but it can. That's where the difference for the aggregation composition. The car, I'm saying it has to have an engine, has to have a color, but for an aggregation, you can say it can't have a. So maybe my aggregation here, maybe the car can have a passenger. So it can have one, but it's not required. It's still a car, even if it doesn't have a passenger. That'll make more sense as you work with it more, but in general, you tend to want to favor. Um, yeah, I believe that's all I'm going to cover for the day. Little early, about 7 minutes, 6 minutes. Yeah, I think that's a good enough stopping point. So I'll make the plan for next time to continue on a little further. Maybe look into inheritance just a little bit and try to maybe write just a little bit of a program. But yeah, that's going to do it for the day. So thanks for watching. This was episode 11 of Programming with Shadow. Thanks. Have a good day.